Hello everyone, welcome back to RESHMI'S. Today we are here with the second class of our topic real numbers of grade 10 Cbse Ncert, and we are moving on to our first exercise, which is exercise 1.1. So let's start with question 1, and question 1 is use Euclid's division algorithm to find the HCF of 135 and 225. Now here, which is a greater number? 225. So we start dividing 225 by 135. 135 ones are 135. We get the remainder 90, which is not 0. So we need to perform the division again, where 135 becomes a dividend and 90 becomes a divisor. So now 90 ones are 90. Balance, you get 45. Here also we haven't got our remainder 0. So we need to perform the division again. So here 90 divided by 45. 45 twos are 90, which is 0. Here we have got the remainder 0, and that step at which we get the remainder 0, the divisor is the HCF of 135 and 225. Therefore, HCF of 135 and 225 is 45. So that was our first answer. Let's move on to subdivision 2 of first question. Now this is the second question, which is to find out the HCF of 196 and 38220 using the Euclid's division algorithm. So let's start dividing the bigger number 38220 by 196. So let's perform the division. That is 196 ones are 196. Balance, you get 681. We take this 2 down. So 196 nines are 4, 6, 7, 1. We get the remainder 8, 9, 98. Again, we take the 0 down. 196 fives are 980. We get the remainder 0. So here we have got the remainder 0. Then the divisor will be our HCF. So HCF of 196 and 38220 is 196. 196. So this is our second answer. Now let's move on to subdivision 3 of question 1. So this is our third question, which is to find out the HCF of 867 and 255 using the Euclid's division algorithm. So let's start a division. 867 divided by 255. 255 threes are 5, 6, 7, and balance you get 102, which is not 0. So we divide again. So here 255 divided by 102. So 2s are 204. We get the balance 51, which is not 0 again. So we perform the division again. So 102 divided by 51. 51, 2s are 102. Here we get the remainder 0. So what is our HCF? That divisor is our HCF. Therefore, HCF of 867 and 255 is 51. So that was the answer of our subdivision 3. Now let's move on to question number 2. So this is our second question, which is show that any positive odd integer is of the form 6 cube plus 1 or 6 cube plus 3 or 6 cube plus 5, where q is some integer. Now this is a repeatedly asked board exam question. It was asked on the year 2012 and 2014. So let's move on to answer. Answer. Let a be any positive odd integer. Okay. So now, what do we know? We know Euclid's division algorithm. What do we know? A is equal to BQ plus R, where 0 less than or equal to R less than B. Now, what is the B here? We take B as 6. Then we get A is equal to 6q plus r, where r is equal to 0, 1, 2, 3, 4 and 5. Now we are going to consider different cases of r, where r is equal to 0, 1, 2, 3 up till 5. Now let us consider the first case, that is when r is equal to 0. When r is equal to 0, what happens? We get a is equal to 6q, which can be written as 2 into 3q. This clearly shows that this is an even number. Now we are not considering any even number of a, so this case is rejected. Now what happens when r is equal to 1? We get a is equal to 6q plus 1. Now when r is equal to 2, what happens? A is equal to 6q plus 2. So this can be written as 2 into 3q plus 1, which is again even, so we reject this case. So this is again rejected. Now when r is equal to 3, what happens? A is equal to 6q plus 3. Now when r is equal to 4, what happens? We get a is equal to 6q plus 4, which can be written as 2 into 3q plus 2, which is again an even number, and here again this case is rejected. Now what happens when r is equal to 5? We get a is equal to 6q plus 5. So this was our question. If we take any positive odd integer, then it will be of the form 6q plus 1 or 6q plus 3 or 6q plus 5. That was our answer for question number 2. Now let's move on to question number 3. So this is our third question, which is an army of 616 members is to march behind an army band of 32 members in a parade, and the two groups are to march in the same number of columns. What is the maximum number of columns in which they can march? So to find out the maximum number of columns, what should we do? We need to find out the largest number which divides both the 616 and 32. So for that we need to find out the HCF. So our answer is to find out the HCF of 616 and 32. So let's start our division. 616 divided by 32. 32 ones are 32. We get the balance 29. I take the 6 down. So 32 nines are 288. I get the balance 8. So here I haven't got the remainder 0. So I need to perform the division again. So again 32 divided by 8. 8 fours are 32. I get the remainder 0. So what is our HCF? Our HCF is 8. So our HCF of 616 and 32 is 8. Therefore, our maximum number of columns is 8. So this is our answer for our third question. Now let's move on to question number 4. So this is our fourth question, which is use Euclid's division lemma to show that the square of any positive integer is either of the form 3m or 3m plus 1 for some integer n. So let's start with, how do we start with the answer? Let a be any positive integer. Okay, a be any positive integer. Then what do we know by using Euclid division lemma? We know that a is equal to bq plus r, where 0 less than or equal to r less than b. Now what do we take b as? We take b is equal to 3, then we get a is equal to 3q plus r, where 0 less than or equal to r less than 3. Now we are going to take the different cases of r. So let us consider the first case, which is when r is equal to 0. What do we get? A is equal to 3q. Now squaring both sides, you get a square is equal to 9q square, which can be written as 3 into 3q square, which again can be written as 3m, where m is equal to 3q square. So this is our first case. Now let's move on to case 2. That is, when r is equal to 1, what do we get? A is equal to 3q plus 1. Now squaring both sides, you get a square is equal to 9q square plus 1 plus 6q. Now from here, we can take 3 common. So what happens? 3 into 3q square plus 2q plus 1, which can be written as 3m plus 1, where m is equal to 3q square plus 2q. So this was case 2 when r is equal to 1. Now case 3 when r is equal to 2. So when r is equal to 2, you get a is equal to 3q plus 2. Squaring both sides, you get a square is equal to 9q square plus 4 plus 12q. Now again 4, you're splitting it and writing it as 3 plus 1. So you get 9q square plus 12q plus 3 plus 1. Now why did I split this? To take 3 common from here. So what can I do? I can take 3 common and I get 3q square plus 4q plus 1 plus 1. Now this again I can write it as 3m plus 1, where m is equal to 3q square plus 4q plus 1. So now we have proved what we want. We wanted to show that if we are taking any positive integer, then its square will be of the form 3m or 3m plus 1, which we have clearly shown here. So this was our question number 4. Now let's move on to question 5. Now this is our question number 5, which is use Euclid's division lemma to show that the cube of any positive integer is of the form 9m, 9m plus 1 or 9m plus 8. So what do we do first? We take, let a be any positive integer. Any positive integer. Then we know by Euclid's division lemma, a is equal to bq plus r, where 0 less than or equal to r less than b. Now here we take b as 3. So b is equal to 3 implies a is equal to 3q plus r, where r is equal to 0, 1, 2. So now let's consider our different cases. When r is equal to 0, what happens? We get a is equal to 3q plus 0. Now we are taking the cube on both sides. So we get a cube is equal to 27q cube, which you can write it as 9 into 3q cube, which is again same as 9m, where m is equal to 3q cube. Next we go on to our case 2, which is r is equal to 1. What happens when r is equal to 1? You get a is equal to 3q plus 1. Now we are going to find the cube. So a cube is equal to 3q plus 1 the whole cube. Now what is a plus b the whole cube? A cube plus b cube plus 3ab into a plus b. So we are going to expand this. 3q the whole cube, which is 27q cube, plus b cube is 1, 3ab, that is 9q into a plus b, which is 3q plus 1. Again, we are going to expand this. So that is 27q cube plus 9 into 3q square plus q plus 1. Now, what do we take common? We take 9 common. So that we get 9 into 3q cube plus 3q square plus q plus 1. This we can write it as 9m plus 1, where m is equal to 3q cube plus 3q square plus q. So this was our case 2. Now let's move on to case 3, which is when r is equal to 2. So when r is equal to 2, what do we get a? We get a as 3q plus 2. Now we are cubing both sides. You get a cube is equal to 3q plus 2 the whole cube. Now we are going to apply the formula a plus b the whole cube is equal to aq plus bq plus 3ab into a plus b. So what do you get? 27q cube plus 8 plus 18q into 3q plus 2. Now we are going to open this bracket. So what do we get? We get 27q cube plus 8 plus 54q square plus 36q. So from here we can take 9 common excluding 8. So what do we get? 9 into 3q cube plus 6q square plus 4q plus what is remaining? 8. Now this you can write it as 9m plus 8, where m is equal to 3q cube plus 6q square plus 4q. So this is what we wanted to show. When we take any positive integer a, then the cube will be of the form 9m, 9m plus 1 or 9m plus 8. So this was the last question of our exercise 1.1. The next class we'll move on to exercise 1.2. So till then, bye.